Thank you very much, Eileen, for the warm introduction. Hi, everyone. I'm Gary Cowan, and I'm the head of digital construction for Kane Group. We're a family-owned, multidisciplined built-in services design and build contractor based in Banbridge, Northern Ireland. We have offices in Glasgow, Birmingham, and London. We provide sort of efficient and sustainable building services solutions for all sectors of the construction industry across all 7 REBA stages for our clients, with 7 in-house teams working together, utilising the latest in digital construction and DFMA workflows with a strong emphasis on in-house design and prefabrication, installation, commissioning, handover and aftercare. We design and manufacture sort of in-house plant room skids, frames, pump rigs, lateral frameworks, modular skids, that kind of stuff. And at Kane, we've spent really the last decade developing our in-house design and BIM capabilities and our prefabrication teams, as well as our on-site teams in researching and implementing groundbreaking digital construction systems and methodologies and cutting-edge emerging modern methods of construction to prefabricate, install and commission complex MEP installations for quite large-scale projects across the UK with quite a strong presence in the London market. Over the last few years, we've been honoured to receive several prestigious awards for several of our projects, which is a testament to all of the team's continued effort and advances in both the digital construction aspect of technology and also the real-world delivery of real-world project successes. It's been really exciting to be here today for my first presentation at BIM Coordinators Summit here in Dublin, and I'd like to thank Ralph and Audrey and Emma Montague for organising such a wonderful event, and to all of our friends here at Autodesk for agreeing to come all the way over to Ireland to host the stage and forming a really amazing lineup of guests, which I'm really honoured to be part of. And also to all of the BIM heroes that are present here today for a good discussion of everything BIM. I'm here today to speak about our journey to creating true digital twins and how we leveraged all these cutting-edge technologies such as VR and AR and XR to really drive the prefabrication and DFMA workflow target. I'll talk about our case study, Claridge's Hotel Basement Works, some of the obstacles that we faced along the way, and then give a few videos of the guys using the systems to showcase the possibilities of the technologies and how the role VR played in the progression of our BIM systems within Kane. It really is used site-wide now on all of our projects. It's an amazing system. So I was born in 1983 and I grew up in the 80s and the 90s, and I remember vividly back as a child how the VR was portrayed in the industry. It was a novelty. VR was clunky, it had low frame rates and resolutions, and it was priced so far from the average consumer that the only real way you could ever experience it would be in an arcade, or if you were lucky enough to work at NASA, for example. So the closest I ever got to seeing VR was seeing it on TV, but even so, at that early age, it planted a seed within me that this virtual reality technology could perhaps someday change the world. And sort of growing up as a teenager through the years, I was witness to the transformation of computer graphics technology from companies such as NVIDIA coming up with new hardware and technologies, all the way from the old master systems that I played with as a child right up to current gen systems that are doing real-time rendering, ray tracing, and insane graphics today. You know, it's really come a far way, and I always kind of wondered when those two technologies would meet again in the future, and luckily it is to say that we're here today at this present time. The modern VR era came back around in 2012, and personally I was lucky enough to get my hands on an Oculus Rift then around about 2018 in a personal capacity, and I was playing on it quite a lot of games for a year, a lot of Beat Saber, a lot of Forest. Anybody ever played that? Really enjoying the technology and sort of understanding its use and enjoying it. And that was just one of the first experiences I ever had in VR. If anyone's ever had this as their first, I think it's really geared to someone of my generation. It's very retro 80s feel to it, where you get to meet a nice friendly little robot. But it really showed the possibilities of the technology, the immersion, how you could see the rendering of locations, and it sort of made me think about the BIM model then as well. So I started looking out into the industry to see all the different software vendors that were offering different VR solutions at the time. And we trialled quite a few of them that were on the market at the time. And ultimately, we settled with a company at the time that were Iris VR. They made a Prospect as the software that they use. And as I say, I think I was right in my guessing, and because recently there in the last few years, Autodesk have actually purchased RSVR and it's now becoming part of the Autodesk XR platform. So at the time when we sort of trialled this software, it was all very new. We were working on the Edgware Road project in 2018. And it was the first model here that we've seen that we actually exported to VR as an initial test run. So when we exported it to the VR, as you can see the MEP model here on the right-hand side, there was over 40,000 elements in the model. So you would think that that's quite a complex model. The first thing that struck us when we went into the model in VR was actually how much of it was missing. There was no clips, there was no hangers, there was no structural supports. It was just a lot of pipes and ducts floating in midair with no real context as to the building structure and overall coordination, and even some spaces where the coordination just simply didn't work. So it did give us a real look at the technology. But the first thing really was the problem with the colouring. So we recently, before that, it took on a fabrication workflow where all of the pipework and ductwork that we were drawing was in fabrication services. And all of the rendering engines that take it out into third parties use the material that's applied to the system, which in this case is lovely Autodesk grey fabrication. So there was a bit of research and development on the first implementation of this technology as to how we could actually colourize our systems. So we found that using the Navisworks workflow actually allowed us to export from Revit to Navisworks, isolate all of the systems and create search sets and rules, and then be able to force colours to the materials, which opened up then the viability of the system to be able to review the models. But again, the first thing that struck me as a building services design engineer with a lot of site experience was that I was used to looking at this on a site context and there was no fixtures and fittings. So we then started looking at all of the ancillary products that we required that have no BIM models in the real world. So all of your pipework clips with phenolic blocks and rubber line clips, slide guides, right down to the ancillary items like valves. We started to create our own in-house parametric library that we had control over and a bit of style and flair with a bit of modelling and branding on the stuff. And this has grew over time then to really encompass all of the objects that we may need to put into a 3D model. We have a high resolution, high fidelity, one-to-one simulation of each socket or switch or hanger, which is fully parametric and fully sort of quantifiable from the digital model. So that was around this time in 2018 we were asked to sort of look at the Claridge's hotel basement, which at that time was an absolutely revolutionary project to get involved in. The hotel had plans to expand on the roof and add 2 floors of luxury apartments for their 7-star VIP guests. But unfortunately, the hotel's existing MEP services lived on the roof. So the only option that they have was to actually dig below the hotel under the Art Deco wing and form a 5-story sub-basement underneath, which would allow then the services to be transferred to the basement for demolition and installation of the 2 new floors, which would give them 20 new rooms and a pool up there as well. So sort of tackled at first by a team of miners from Donegal in Ireland. They successfully excavated and constructed the 6-story sub-basement, all while the hotel remained open and trading above their head. Constantly monitored by lasers from all the surrounding buildings looking for subsidence or shifting in the building. And I was told by the engineers on the ground that the building actually sank about 15 millimetres in total. So it was an impressive feat, it really was. And we were really keen to get involved. But site constraints meant that we had no room to work or the ability to weld so deep underground, so that we knew we had to go prefabricated and I had to come to site and go together just like a big Lego set. So our production facility and design teams are based here in Ireland in Banbridge, so we had limited access to the site just by sheer distance alone. But works on the site and the fact that the hotel remained open and trading placed huge restrictions on the site access and duress, noise, logistics. So we knew straight away that we needed to design and coordinate totally off-site and remotely in the cloud using an as-built digital twin of the basement. With our friends at Leica Geosystems, we commissioned a point cloud survey to be undertaken of the entire constructed basement from B5 to B1, which provided us with a millimetre accurate model of the as-built concrete substructure. It pointed out the differences in the outset, sloping walls, for existent at the bottom here, and sloping columns as well, with the building tolerance factor basically removed completely. This was then used in a scan to BIM process, using the Lego Cloudworks to construct a highly detailed and accurate as-built structural model, which then was used as the backdrop for the MEP design and fabrication model. And that ensured everything that we designed and detailed would fit with 100% certainty. The access down to the 5th floor at the bottom was limited by this shaft, and this was the main access and egress for the entire site. It measured 3.5 metres squared, probably 4 metre at its widest point. And we really had to analyse this shaft in totality and ensure that everything that we designed and prefabricated and indeed bought from manufacturers would fit down this hole and be able to be suspended and lowered about 35-40 metres down into the substructure of the building. The model was used for sort of every floor was covered, and the scan to BIM gave us unique certainty of exact placement of concrete columns and downstand beams, and allowed the BIM team to work remotely in total confidence that there was not going to be any surprises when the stuff arrived on site. So the model was used for preliminary asset placement for all the big stuff like boilers, chillers, pump rigs, all the vessels. And then on B4 there was 27 air handling units that had to be arranged on the floor, some of them double stacked, where we provided a steelwork frame option and solution as well to the client and prefabricated all that in-house as well. So most of the modelling was reviewed constantly in VR by our senior design team and directors, who were not Revit professionals, not Revit proficient, but were able to interact and review with the models independently of the design team, ensuring that there was no downtime for any of the technicians for reviewing. These guys are all site-based and moved into managerial roles from being on the tools. So it's a much more natural interface for those guys to review a digital model in a format that's much more natural to their way of thinking. If they're used to walking onto a building site and looking at a building, it becomes almost second nature to slip on a headset and walk onto a digital site and see the same. And that's why the level of realism and the level of simulation that we put into our models is so important, that it is a real one-to-one simulation of the model. It was used by the teams both in our head office in Banbridge and also in remote locations in our other offices across the UK, and also indeed on site. We had a special VR room constructed on the Claridge's hotel site, which allowed anyone access to the VR model, from boots on the ground to management to the client themselves, for design reviews and decisions to be made very, very quickly. The accuracy of the background structure sort of allowed real in-depth design solutions to be pre-manufactured and installed. For the example here was that the eastern wall had a very distinct set or a kink in it. So we were able to see that well in advance, and we were able to plan out how we would arrange our wall-based framework laterals to ensure compliance and fit. And here you can see on this, on the left-hand side is the fabrication model, and on the right-hand side is a point cloud scan taken of the as-built finished asset. And you can see that it worked out extremely well for us. You know, it all went in millimetre accurate, no problems at all. No surprise work on site, because we didn't have the ability to just take out a grinder and start grinding these pipes and ducts on site. Everything had to come in a distinct sequence, in a distinct order, and be installed under very strict time. The collaborative nature of Iris is fantastic. So again, as I said, we have offices across the UK, so distance is no longer a problem for us for collaborative working. We can have design managers in Banbridge and site operatives on site working together, and you don't actually need a VR headset as well. I know Jonathan talked about some of the limitations and people feeling sick. The system is also available without a VR requirement. If you just want to use a laptop, it works with a laptop as well. So for people who can't use VR at sickness, it doesn't limit them from the experience, the overall experience, and using this as a viable way of inputting. So after a lot of effort by all of our team, we were left with this absolutely amazing model, LOD 400. Everything modelled from pipework, ductwork, every single goalpost hanger, every clip, every screw, nut and bolt has been modelled in this model, and it opened up a number of avenues for us in sort of digital quantification. It really brought our Revit modelling to such a high standard from previous models that we would have put out in previous years that were very bare and scant. Our models really look at every scenario. We look at hanging, we look at support. We don't leave it to the site operatives anymore now to figure it out on the ground or take time, head scratching and thinking. It's all done in the digital model. It's all preset out. And all of these tools, such as the construction cloud, give immediate access to all of our team members, no matter where they are, on whatever device they're using. So all of our site operative guys use tablets and are able to spin straight into the models, go where they need to go, create issues, track works. It's an amazing system. You can see the level of detail that we went into. That most of it was all prefabricated and came over in kits, and then was all just put together, as I say, like a very large mechano set. And you're seeing a mixture of technologies here at the minute. This is BIM 360 that we're using to review the models. Revit itself is very slow. It's very hard to navigate. By publishing our model every day onto the BIM 360 platform, we can use the surrounding technologies to increase workflows and increase the speed of using these technologies. And this is the air handling unit floor in Prospect. Using it as the VR, you can see the level of detail that you can get from these systems, and the immersion is amazing. This is kind of the dollhouse mode, I call it, sort of an overview looking into the model, and then you can sort of get right down into the guts of the model and navigate around. So this is great for, as I say, site-based guys. You can imagine the sequencing of this installation was crazy, the amount of layers of ductwork and stuff. So this technology allowed us to really inspect this system and understand the order of installation of layers of ductwork and fixings and fixtures, as well as being able to put our precision coordinate system into the model to ensure that all of the air handling units, you can see the coordinate markers on the floor, that those machines would be positioned exactly in real life where we wanted them to be, so that all of the prefabricated items coming would all connect and play nice and build together like a nice big Lego set. So you can see there's quite immersive in the experience, and you can sort of see the level of detail that we go to. We sort of leave no stone unturned. Doing a bit of downward about here, yeah. So we were able to, this is a picture of the as-built asset there. So, we were able to interface really early with the client and talk about things much earlier than we would have thought later. So the client wanted a Google-esque plant room, highly coloured. So we were able to provide screenshots, media to the client with different coloured solutions really early on, so that there wasn't sort of a final thought and a scramble at the end. And it was really satisfying for the client because they totally understood what was being designed, what was being fabricated, and what was being delivered. So when the lorry started appearing to the site with all of the Kane branded stuff, the client already had walked this and stood in it and seen it for himself and knew that exactly what was to be expected of all the installation. You can see the level of detail, and this is the problem that we find in some of the AR solutions that we have. The level of detail that we put in just can't be translated at the minute. We're limited by technology at the minute, but fast forward 5-10 years, I don't actually think this will be a problem. I think this will be a thing of the past. So it's kind of become our showpiece, this model. A lot of work went into it. Probably about 10 or 15 technicians worked on this model for the guts of about a year and a half. And we're still actually playing in it at the moment, just for marketing and media. And we recently did a reality capture of the entire basement and overlaid it with the BIM model to see how close we actually got, and it's actually scary how close most things are. There's only a tolerance of a couple of millimeters here and there, and it really is an amazing technology. It revolutionised everything for us and was just a really positive driving force forward. So after the success of Claridge's and using it in a confined space, we thought about the scalability of this technology. Let's look at it across huge distances across huge sites. So the next sort of job we got involved in was the Cowan estate. And what we had to do there was we were doing a lot of district heating, cable runs in the roads, had to do quite a lot of liaison with the civil guys and the structural guys. So once we received all the layouts from the civil guys, we translated them through 3 dimensions and put them into the model. We were able to use Aris for a complete site walk and check that all of the infrastructure was correct and all of our mains, water lines, district heating, gas, all did what they were meant to do and pass each other in the landscape. So we had to work very closely with the landscape architect. We had to work very closely with the civil and structural engineers and the main architect on the scheme to coordinate this. So this was an experiment that we did in that it was a virtual site walk, and I screen grabbed and recorded this. Basically walked the entire site reviewing the civil guys' design, was able to flag all the positions where there was clashes with the manholes and the infrastructure design, and almost hand doodle and sketch over the top of the design in 3D and give him almost a walkthrough video of all the changes that need to happen. And instead of passing him a massive A0 sheet with scribbles all over it and notes that are hard to understand, it was a very intuitive human way of just showing someone, here's where the problems are, here's what I think we should do to fix it. And the turnaround on that design was remarkable at the time. And as I say, we sort of push all of our clients to try and utilise this technology. So in summary, really the impact of VR for us, as I say, it totally driven the quality of the models. It was a trousers down moment in Revit. You know, everything was laid bare. So it really pushed the excellence of Revit and 3D modelling, parametric modelling, which had a lot of positive outcomes in digital quantification, certainty, and prefabrication and DFMA workflows. It sort of it increased the interaction of the BIM model within the whole company. So traditionally, it was maybe only the BIM guys and the design guys that really looked at the model. The operations guys only ever looked at 2D drawings. It has revolutionised that workflow now that the guys on the site really do look at the 3D model and they look at BIM 360, and we hope to roll out AR technologies for the boots on the ground. So it's pushed BIM adoption company-wide, it really has. It's increased the collaboration of more stakeholders, so more people are looking at the models than ever before, the client, senior design teams, directors levels, and it comes with some assurance then as well from senior people that things are happening the way they're meant to be happening. We've found a marked decrease in sort of modelling errors and clashes because, as I say, when people enter the model and they look at what they're drawn, they understand it a lot better than trying to analyse 2D layouts and hand sketches. And we also find it very good sort of interactive training session for all of our new recruits into the BIM technology. A lot of the younger generation coming through don't have site experience, so we're asking them to draw large-scale MEP systems, ductwork, pipework. They really don't know what it is they're drawing, and without having to put them on a plane to fly them to London to stand on a site and see it, it gives us a sort of cost-effective way of letting them have an understanding of the scale of the projects that they're working on. So technology's moving very, very quickly as well. Certainly when we started the VR path a few years ago, it was very much a tethered experience with a Rift, and you needed a very powerful PC to be able to run this technology. In more recent years, we've started seeing the explosion of the standalone headsets, Quest 2, Apple Vision Pro, and certainly, as I said, the technology is moving very, very quickly, and I do definitely see some of the problems that we have today in scale and complexity disappearing in the next couple of years as the hardware powering these experiences gets faster and faster. But at the moment, we're kind of transitioning to a sort of semi-untethered setup, and really the impact of that is just a bigger workflow. You have to segment your models much, much smaller to be able to use a standalone headset, but we sort of weigh it up with each thing that we're considering at the time, and it is working very, very well with our teams. So AR, again, is something that we have toe-dipped into in the last year or two. The first thing we demonstrated was the Trimble XR10 headset, which is a head-mounted unit, so it's direct in vision AR, and it was actually very impressive technology. The tracking was very good, it sort of held its drift very well. What I didn't like was in very, very bright sites, it was quite hard to pick up the hologram at times, but since that, I've seen that Trimble have actually come out with a sort of cool clip-on sun visor that you can clip on. It proved a concept for me that AR was legitimate, and it is definitely something that will be a very valuable tool, I think, in coming for QA and model checking. But I just don't know if it's quite there yet, just with the interoperability of all the different softwares and the complexity of some of the models that are being presented, So we have a pin in AR at the moment, and it's definitely something that we're going to spend a bit of time this year looking at and implementing. I think it's a very interesting technology. Not only just for head-mounted displays and thingy, but also in device, picture overlay. AR is very important. I think a lot of our guys and ladies on the site have these devices in their hands, and it would be an awful shame not to be able to use them for the AR experience. And just to try and increase the workflow of model detection and correction, it's our QA engineers are forever running about with drawings trying to verify stuff. And I think this definitely will make that process a lot easier at the moment. As I say, there's many different technology providers out there at the moment, and we're currently looking at several at the moment. Gamma and Trimble and XYZ are 3 of the ones we're considering at the minute. So we'll see how that plays out in the next couple of months. And that's me finished. If anyone has any questions, I'll be happy to stay at the end. Thank you very much for your attention.